Good morning, students. In this video, we are going to discuss about capacitance and capacitor for class 12. What is capacitance? Capacitance is the ability of body to store an electrical charge. Any object that can be electrically charged exhibit capacitance. A common form of an energy store device is the parallel plate capacitor. So we can say that the capacitance is the ability of body to store a certain amount of charge. Now the question arises, what is capacitor? A capacitor is a device for storing electrical charge. The capacitor consists of a pair of conducting plates separated by an insulating material, for example, oil, paper, and air. The measure of extent to which a capacitor can store charge is known as capacitance. If we calculate the formula of capacitor, it is C equals to Q by V, where Q is the charge stored and V is the potential. This is the diagram of capacitor. Here we have two metallic plates which are parallel with it and an axis of free electron. That is a symbolic representation of parallel plate capacitor. What factors affecting the capacitance? The capacitance is only a function for the physical dimension of the conductor and the permeability of the dielectric. The formula of C is given as ER epsilon naught A by V. So we can say the capacitance depends on following factor. Number one, area of the overlap plates. Epsilon R, relative permeability of material. Epsilon naught, electric constant, and D is the separation of plates. How these factors affect the capacitance? If we talk about the plate area, if the area is greater, there is more capacitance. If the area is lesser, there is less capacitance. So we can say greater plate area gives a greater capacitance. Lesser plate area will give the lesser capacitance. So capacitance of a capacitor is directly proportional to the area. The second factor is plate spacing. All other factors, if being equal or constant, for the plate spacing gives less capacitance, closer plate. So we can say that the capacitance of a capacitor is inversely proportional to the plate spacing. So for plate area, capacitance is directly proportional to plate area. For plate spacing, it is inversely proportional. The third factor is dielectric material. All other factors being equal, the great permeability of the dielectric gives the great capacitance. So we can say that the capacitance of a capacitor is directly proportional to the dielectric material. So if we summarize in these points, the capacitance of a capacitor depends on a three factor. Number one, area, which is directly proportional. Spacing between the plates, inversely proportional. Dielectric material, directly proportional. Now the question arises, what is the dielectric material? A dielectric material is an electric insulator that can be polarized by an applied electric field. When a dielectric is placed in an electric field, electric charge do not flow. So it is known as dielectric polarization. While the term insulator implies the low electrical conduction, dielectric is typically used to describe the material with high polarizability. The term insulator is generally used to indicate the electric abstraction. If the space between the plate of a capacitor is filled with a dielectric, the capacitance of capacitor will change compared to the situation in which there is vacuum. The change in the capacitor is caused by a change in the electric field between the plates. How? The electric field between the capacitor plate will induce dipole movement, which is the reason why we are getting the different values. That is the relationship. If we calculate the potential difference in the term of work done, the potential difference is equals to W upon Q, force upon charge. That is a relationship of capacitance. If K is larger than 1, the capacitance of capacitor can be significantly increased by filling the space between the capacitor plate with a dielectric larger A. The electric field between the two capacitor plate is the vector sum of field generated by the charges on the capacitor plate. Field generated by this E equals to sigma upon E, where sigma is the charge density, linear charge density. It will convert V into V by D. So that is the final formula of capacitance of a parallel plate, which is given by A epsilon naught B, where A is the area of plate, epsilon naught permeability, D is the distance. So in this video, we have learned what is the capacitor, what is the standard formula of capacitor, and how the capacitor for a parallel plate capacitor is calculated. Thank you.